Hello, hope I'm audible and the screen is visible. We will start in a couple of minutes, but before that, if you see any technical issues, please let me know. Great, thank you. And if you notice any lag or something like that, please let me know. This holds for all the classes. Anytime you're not able to hear me or you think there's a huge lag, please let me know. We'll start in a minute or so. Okay, let's get started. I noticed a network issue, so I've changed networks. Let me know if there are any issues during the class anyway. So welcome to the week 6 live session for the CS104 course, and let's go through this quickly. I think by now all of you should have attended at least one live session, but I'll do it anyway, spending a minute on this. So we have 2 of these sessions per week. You can attend whichever works for you or even both. And how these sessions work, we will mostly focus on problem solving and a good recap of that week's course content. And this is mainly a forum for you to ask doubts and questions, and in a live interaction format, right? You always have the discussion forum where you can post questions and receive answers, but this is intended for an interactive format of answering, right? So feel free to ask questions anytime, and it's okay if it's not really an assignment question. If as long as it's relevant to the course content, feel free to ask. And this live session, you will get access to the recording as well as the slides after the session, so you don't need to worry about that. So this is a 2-hour session, so we'll have a short 5-minute break around the 8 o'clock mark. We'll have 45 minutes of recap and 45 minutes of problem solving, which leaves 30 minutes for all your doubts and questions. So make the best use of this by asking as much as you can, and even if it's from an earlier week, that's fine at this point, right? If you have a doubt from any of the week's course contents, please ask me and I'll try to answer it either in the same session or in a subsequent session. So with that, let's get started. So since we're at the midpoint of the course, right, this is week okay, this should be week 6, sorry about that. So we're at the midpoint of the course. So how are you guys finding it? Any general comments or anything that you're finding difficult, or is it all manageable? Just want to get a sense of how things are going for you. And this is so that the live sessions can focus on those things that are difficult for you. For instance, if you say that the assignments are very tough, we can maybe try and include more problems. or if you say that some aspects of the lectures are not really understandable, we can go a little more into that in the next session. So again, use this as an opportunity to bring up things that you have a problem with, right? This whole thing is intended primarily to help you guys. So anything that you're facing an issue with, or if there's nothing, that's also perfectly fine. That's great. It means that you're doing really well and everything is clear. So let me know about that as well. I'd be happy to hear that. Any thoughts? I'll give you 30 seconds. Think about it. Would be better if we get more learning atmosphere with programming. Yeah, that's a valid point, right? With a course like this, which is intended to be very hands-on, it's hard in this format that NPTEL currently has, which is mainly that you get recorded lectures. So you basically get a demo session, but some of the demos you might not be able to do it in parallel unless you have access to those compute resources. But wherever it is possible, right, like some demos are shown simply with containers or Kubernetes or something like that, which you can do on your laptop. If there are things like that, as much as possible, try and do the demo while the video is going on, as in pause the video, do whatever they are doing, see what results you get, rather than completely listening to the lecture and then coming back and doing things, right? So that, because I feel if you do it hands on in parallel with the video, you kind of compare what you get versus what is shown on screen, and you learn a little bit from that. Whereas if you do it completely offline at a later point all by yourself, you might not really pay attention to the results or the output that you're getting. So that's one suggestion. But in the current format, unfortunately, these live sessions are not meant for programming or hands-on things like that. If that changes at some point in the future, that would definitely make it more valuable for you guys. So feel free to mention this in the NPTEL feedback forms as well, right? So those things are taken into account while designing a future iteration of the course, or even while relaunching the same course for the next time. But till that happens, I think you have to try and do this on your own. But I think you will get the best value out of this course only when you try out things that are taught in class, right? If, for instance, this week's a lot of things are about mixed precision, right? No matter how much you listen to what mixed precision is, it is not the same as running an example with mixed precision, right? So see the code snippets that are shared in class and see if you can run them and understand. If not, things like PyTorch or TensorFlow, these frameworks usually have good documentation with examples. So that would be a good starting point. You could try and reproduce those and see if you understand those, right? But as much as possible with this course, try to do stuff hands-on, so that you kind of appreciate the concepts beyond just their definition and what they stand for theoretically. Yeah. Any other thoughts, comments, questions? Finding something very difficult? Are the lectures easy to follow? Again, the course has 4 instructors and all of them have different styles of teaching, right? So do you find the lectures easy to follow, or are some things really difficult and you would like more time spent on certain concepts? Anything like that? Lectures are quite specialized, makes it easy to understand but difficult to follow. When you say difficult to follow, do you mean difficult to kind of run on your own? Apply, okay. Right, that's the whole point of it. That's what I've also been hinting at, right? It's fine if you understand the concept, and a lot of the assignments just test you on theoretical understanding of concepts, but that's not really the point of the course, right? The point of the course is to apply these concepts in practice. So yeah, with the way the course is currently designed, that might be a little difficult for you to do. But again, like I was saying, there is no way around it. You have to kind of try it out on your own as much as possible, and in some places you might not be able to, so then there, see what is an equivalent version that you can do on your laptop. So yeah. Hi, good evening. Do you have a question or a comment or something like that? I was just asking everyone else about how they're finding the course. Since it's been 6 weeks, it's the midpoint of this 12-week course. So I was just asking for feedback on what you guys find difficult or what's challenging about this course, so that we can try to do some of that in the live sessions. Yeah, going back to that, so for instance, if some output is shown on a GPU, right, and you don't have a GPU on your laptop, there's probably not much you can do to reproduce that. But again, check around on the website, check around on the internet. For instance, you might have some cloud credits, right, because you're all students, and most of you at least are students, and you have some academic licenses or some credits available from a lot of these cloud service providers. So you might actually be able to use those things and then do the same things that is being shown in a demo, but you will have to explore that. If you're looking for something particular like that, right, you can drop a note and then I'll try to see if there are any resources that can help you do that. PyTorch code file is not there. So is this for a particular example that was discussed in the course, or is it in general about all lectures and demos that are shown to you? Okay, either way, feel free to ask that on the discussion forum. Sometimes the instructors and the TAs might have access to those code snippets, and they might share a link to them or the code snippets itself on the same thread, right? So I think I saw that being done for 1 or 2 questions, right? So yeah, which one was it? Yeah, I'm not sure which one. I can't find it here, but I saw something like that being done, where a notebook was shared or something in the PowerPoint presentation itself was pointed to as a link to a notebook. Yeah, I think these demo links, yeah, so the TA has answered saying that you can find the demo links in the PPT, and some demos are also uploaded in the course page. So take a look at that and see if you find what you're looking for. If not, again, feel free to ask on the forum, right? Because the TAs and the instructors check this out fairly frequently, so they will have the code snippet, so they might be able to share that with you. But if not, if it's a simple thing, where in the course page? Good question. I have not seen those. I've seen the slides, I've seen the videos, but I have not seen the code snippets. Has anyone else seen them by any chance? No? Nobody has seen it? Okay. If not, if you're not able to find it, then please reply back on that thread saying that it's not in the course page and where can I find it, right? That should get you a reply from the same TA, and they'll probably point you to where you can find it. She also says that some links are there in the slides itself. So see if that's also there. That might also be there. But if not, please ask on the discussion forum. You should be able to get access to those at least. Yeah, I don't see them on the course page either. Okay. They're not there in the slides as well, is it? Okay, I'm guessing so from your answer. So then please raise it on the discussion forum, especially if you're looking for a particular week's demo notebooks, ask saying I'm looking for this. If you want for all the weeks, you can also ask for that, saying that it's not there. And then even if you get a reply saying that it's there, ask where exactly if you're unable to find it, right? And this is, you should get a reply in a day or two, so please ask. Week 6 demo. Okay, I see. You can ask. I unfortunately don't know, since I'm only a PMRFTA, so I get access to the same things that you guys do, nothing extra. So I have no idea about where who would have these demo notebooks. So the official TA and the instructor would be able to help you with that. Okay, any other questions or comments? I'll also drop a note to the TA about this. So no, for you, the way to connect with the TA is through the discussion forum. So the person who's been replying on all the questions is also the person who does the other live session. I think she would have access to all the notebooks. So you can simply ask on the discussion forum, but I will, after this session, also check once on that, saying that people need access to this. So let's see, but you make sure to ask. WhatsApp group, unfortunately, officially is not encouraged. If one of you wants to do it, feel free to go ahead and do it if you feel it would be beneficial. So, but NPTEL officially says that they do not do this, which is, as an organization, that's fine, right? Because in case someone misuses it, then they have no idea about that, and that creates a lot of issues. So NPTEL officially does not have a WhatsApp group, but you, as if you feel that it would benefit people, whoever is interested to join can join, and you can create and share the link with people. That's completely up to you. No harm in doing that. Anything else? Okay, if not, let's get started with the recap part. Okay, so broadly we looked at optimizing deep learning training in week 6, right? So a few of the ways to optimize training was mixed precision. Then again, we looked at automatic mixed precision. So by now you would have seen this pattern. I've pointed this out multiple times, right? Whenever there is a framework or a library that comes into play, the first thing that it tries to do is to give the user an option to implement this particular feature or use this particular feature. The next step that everybody appreciates is when the doubt in path directory. Yeah, please post your question on chat. I'll take a look at it afterwards and then get back to you. Maybe if we have time at the end of today's session, if not the next session, but please post it anyway. Yeah, so going back to what I was saying, so the next step that the library does is to kind of automatically do it, where a user has to simply set a flag and say I want this feature, and then the library takes care of exactly how it needs to be implemented, right? So that's again one higher level of abstraction for the user. They don't have to deal with the details. So again, you'll see this path here, just the way last week I think you saw some tf.data.autotune or something like that, right? And then we look a little more into mixed precision training, and then we'll move on to transfer learning and look at NVIDIA Tau as a framework or a library. So this is broadly what was covered in week 6. Again, if you have a doubt in any of these topics, or if you feel I didn't understand anything about this particular thing, please ask it on chat, and we can make sure to spend an adequate amount of time on it. Because these days I think the questions that I have are all very theoretical, right? So at best it takes 2 minutes per question. We are done in 30 minutes. The recap also takes 30-40 minutes. So we have more than enough time for doubts and questions. So please feel free to ask questions. Yeah, so optimizing deep learning training is basically finding out methods to tune a deep neural network to minimize losses and achieve the desired accuracy. So again, last week we discussed some metrics for accuracy, like the top n error, right? And we have various doubt in the coding part. Okay, so if it's a particular line of code or something that you can kind of put in chat, that would help me understand what the doubt is, right? Or if you have trouble understanding an entire code snippet, let's say on a particular slide number in a lecture, again give me the slide number and the week number, and then I can put that into the recap slides, and then we can discuss it. But let me know exactly what you have a doubt with, so that we have a way to kind of look at it together, right? So now coming back to optimizations, again this tuning a deep learning network could be in terms of the learning rate, could be in terms of the weights, etc. And okay, first thing is how to run that code in my Jupyter notebook or path directory doubt. Okay, so are you referring to the part where in the demos they kind of execute it remotely but kind of do an SSH tunneling and then view it on their local systems? Or you're trying to run it locally, right? And the code runs on your system and you're trying to set up Jupyter, and you have some doubts on what the path should be. Is that correct? Okay, so again, without seeing exactly what it is you're trying to do, maybe one thing you can do is to post it on the discussion forum, if not the chat box, right? What kind of code you're using, where exactly is this path that you're putting in, and what error you get. That might help me understand better as to where exactly the error is. But before that, I will also share, if you haven't already taken a look, I will share maybe a kind of basic demo or setting up Jupyter, right? That should hopefully help you. But if not, we can always take a look at it. If you put it on the discussion forum or the chat box as to what exactly you're trying to do, and then let me find a good demo that I can share it with you. So you've already installed Jupyter, right? There's no issue with that. If not, I'll send you the installation documentation also. I'm assuming yes. If not, please correct me. You run on Windows, okay, and now you have Ubuntu, okay. TensorFlow code in Jupyter, again that should be possible. Let me send you a link. I'm assuming you have, I'm not sharing anything else other than the presentation. I'm trying to find a link right away and send you something. I'm assuming you have TensorFlow installed, right? You're just trying to access it through Jupyter. So for anybody who hasn't installed, since it looks like a bunch of you have issues about Jupyter, let me anyway share the installation page as well. So this is just in case you haven't installed it, and most of these comments would typically work with Linux, right? Especially when you see a command line thing. So if you want it for Windows, you'll have to look particularly for that. Let me do that as well and send it to you. Install Jupyter on Windows. Yeah, I think this should work for Windows as well, as long as you install pip. So if you see a pip install kind of command, please install pip as well before and then run this command. It should work on Windows as well. So this installation part should be fine. Now let's come to the next questions. Jupyter and path. So I don't really know what path you're referring to. So maybe I'll give you a few examples from the official page, and then if that doesn't help you, please post a detail. You want Jupyter Notebook installation for Ubuntu. You can still follow the same pip install, right? And that should work. And then I'm assuming you have, it is a GUI thing, right? Because you said Ubuntu. So you should be able to open up a browser and run things. So what exactly is the issue with Ubuntu? Is it an installation issue? Oh, it's an installation issue. Okay, let me see. I think there's a basic page here. This is probably a little more detailed than the previous one, although it's not from an official web page, but you can use this. So it's very simple. Install Python, install pip, and then install Jupyter Notebook, launch Jupyter Notebook, right? So this is it. So are you getting some errors after you follow these steps, or is it something else? Okay, in parallel, let me look at the TensorFlow and Jupyter and see if I can give you a few examples. Oops, skip the slide. So again, installing TensorFlow. So if you've not installed TensorFlow and you want to know how to do that, you can follow this. Again, it's from the same website. Seems fairly simple and straightforward. So you can follow this, try it out, and you'll know if TensorFlow works. Then you can try out some of the more sophisticated demos. So hopefully this helps both the people who ask questions. If you have any other specific questions, again ask me. Since we have a lot of time in these sessions, maybe I can do it right away and give you like a short answer to things. YOLO 5, okay. I think I have a little bit about YOLO 5 in today's content, but we can definitely take a look a little more in detail, right? Things like how does it work, or what is the architecture of YOLO in general. So I think recently there has been YOLO V8. So yeah, we can talk a little bit about all the YOLO models in general maybe next week, because I don't have detailed content today, but we'll make sure to discuss it next week. Any other questions before we move on? Which YOLO is good? So YOLO again comes in a bunch of sizes, right? When I say sizes, I refer to the number of model parameters, or which indirectly translates to how much memory it takes. Whether you're doing inference or whether you're retraining YOLO, how much memory that's going to take depends on the size of the model, right? So based on this, again, you have different varieties or variants of YOLO, right? From nano, small, medium, large. I think there's even an extra large, and there's also a YOLO tiny variant. So depending on how much accuracy you want and how much memory you have on a particular system, you can pick the variant of YOLO that you want to use accordingly. And again, you can pick the later versions of the model if you want some new changes that have been done, or you can go with an older one also. So that's broadly how I would think of selecting a model. YOLO, yeah, I think you should be able to. The one that Ultralytics offers, I think, should be pre-trained. If you want to do something specific with it, you can always do like an incremental retraining, but otherwise it would be by default a pre-trained model, if I'm not wrong. Yeah, it looks like it's a pre-trained one. Most of the models that you get from these standard libraries mostly are pre-trained. Yeah, I'm not sharing anything else. I'm just looking at some things on the browser. So anyway, let's go back to what we were discussing. So yeah, so here when we talk about tuning, we could be talking about the learning rate, the weights, etc. And an example of an optimization algorithm, which I'm sure most of you have heard of, is gradient descent. Again, if you've not heard of this, it's a good idea to go look it up. It will give you a little insight or intuition into understanding how a model kind of reaches its optimum, and basically what's called convergence, right? Discuss on path directory. So I'm not very sure what you mean when you say path directory. Are you trying to add something to the system path? Are you trying to set or trying to access something through Jupyter? I'm not very clear on what you're trying to do. So if you can tell me a little more about where you get an error or what's causing an issue for you, then that might help me understand. Okay, let's move on. So yeah, so gradient descent, again, as a broad class of algorithms, has many variants, right? So there are a few common ones that you might have heard of are stochastic gradient descent, mini batch gradient descent, and momentum, right? So stochastic gradient descent works on every individual sample, right? Basically, the gradients are updated after every sample is processed. Mini batch is kind of batching. Basically, you say that I'm going to take 16 samples or 16 images, and only after that I'm going to update my gradients. And there is another extreme where you only update it at the end of the whole epoch or after it has seen all the samples, right? So you can think of these three as three different points along that spectrum. One where the gradient is updated after every sample, one where it's updated at the end of the epoch, and one where it's updated in batches. So those are the three variants. Worked on path directory in Python, but in last class path directory is very different and I don't understand. Can you give me an example, maybe a slide which actually talks about this path, or which has a variable as this path? Some code example, or if you watched a video and there was something, you can tell me the time from that video. You can take your time to do this. We'll also have like a 5-minute break around 8 o'clock, so you can training path and testing path. Was this the data set path? Feel free to ask your questions anytime. I will come to them right away, or if it needs more material, I will add it and then discuss it in the next class, but feel free to ask. So by train path, test path, are you referring to where the data sets are stored? Week 2 is fine, feel free to ask. Since there are no other questions from week 6, we can take week 2. Demo file, okay. Where in the video, can you tell me? If you give me a time, then during our 5-minute break, I can kind of go look at that snippet and then come back, because playing the whole video right away would take a lot of time. You can do that and let me know once you have like a time or a slide. Either one works. I can take a look at it. Yeah. So, yeah, what was the question from week 2's contents? We don't really unmute because there are a lot of people, and then it tends to get chaotic. So I prefer the chat box. So if you don't mind, please post your question on chat, because I can't keep track of who's talking and things like that in the middle of the lecture. Okay, you did not get the demo file actually there. So was there a link to a demo file that did not open for you, or are you referring to something else? If you're talking about some notebook or something that was shared in a slide, please send me a link on the chat box so that I can open it and see what you're talking about. Okay, and what is the other question? There is no link. So you want the link to the demo file, is it? Week 6 demo file? How can you practice Kubernetes cluster, etc.? Yeah, Kubernetes should be fine even if you don't have access to some GPU machine or something like that. You can try out, first of all, setting up Docker Kubernetes on your laptop itself, the one that you normally work on, and then try out some of the demos. I don't see, maybe you cannot spin up too many containers given that you have a very resource constrained laptop. You want a demo file link, or want to understand it very well? Demo file link, again you will have to ask in the discussion forum. You might be able to get it, but I was asking about the path that you're referring to, right? Is it there in some part of the video? Then I can look at it and understand where it is. Yeah, So for Kubernetes, again, I can maybe send you a simple installation file that should help you. But most of these things by default, try them out, right? They wouldn't be too difficult. So look at the official pages always. For instance, look at a Kubernetes documentation. So I'll share the link to Linux and then maybe Windows as well. So by default, try out the instructions that are given on the official pages of each of these tools, right? And depending on what OS you have, search particularly for instructions with that OS and then try that out. And if you run into errors, a good way to, if you aren't able to debug them on your own, a good way is to look at things like Stack Overflow and other platforms where people would have already asked these questions, right? So again, check on those platforms if there are answers to your questions. If you're still unable to find answers, then ask on the discussion forum. Week 6, class 4, 3:55. Thank you so much. So I'll do one thing in the break. When I get a chance, I'll take a look at that and then see if I can find the path that you're talking about. Cool. Let's keep moving because we're 45 minutes. But yeah, feel free to ask such questions in the middle. It's fine. So yeah, we finished gradient descent. So then what are some advanced optimizations we can do in the training phase of things? Again, like I was talking about when someone asked me about YOLO. Okay, in this video there are a lot of paths. Okay, got it. I'll see what those paths are and then maybe tell you. Let's actually do that since you've given me a time. I can do that. 3:55. Okay, so these are all so one path that I see here, for instance, is where the data set is, right? I think exactly at 3:53 or 4 I see that where there is an ls on the data download directory. So that's basically wherever you have downloaded the data set, right? So first you need to download the data set, then whatever you see here you can replace it with where you have downloaded the data set. That is about it, nothing too complicated. Then what else? Yeah, then there are a number of folders that are created for the models, right? So you're pulling models from NGC or NVIDIA's this one. So you want to understand the data directories. Okay, let's see what. So in the initial part of the Jupyter notebook, there is a section where you set up your environment variables, right? So you set your data download directory, you set your experiment directory, etc. So here again, this is a system where there is a slash workspace, and after that they have different folders called data, classification, specs, etc. So what you will need to do is you have to give paths according to your system, right? So if you're working on a Linux machine, typically your default path will be something like /home/user, whatever your username is, right? So if you create a folder there, then you will see something like slash, let's say you're creating something for this course, right? So you might see something like this, home/username/this, right? So you can set up these environment variables accordingly. But what you need to make sure is to kind of have the data set downloaded onto these paths. Only then will it work, right? Because after a while you're doing an ls on it and then you're feeding this path to other things. So you want to understand overall about paths, I'm guessing that is the main question that you have. So let me see if I can share a link quickly. Again, this is a third party site, but seems to be reasonably easy to understand. So if you're new to Linux and you're trying to yeah, this one is from Red Hat, so this might also be more useful. So if you're new to Linux and you're trying to do some of these things, then a good thing for you to do would be to look up like a cheat sheet, right, which basically has prominent commands that you would use in Linux. And yeah, you need not learn all of them, but some of them, like an ls or a pwd, things like that, will help you in understanding paths or cd to change directory, right? So look at some of these cheat sheets online and print those and keep them handy, right, so that you remember what these commands are for. So if you're new to Linux, again, a lot of these things will seem very difficult because you've never really done this before. But yeah, this will definitely help you, where you have a list of commands and you can always look up. Yeah, Ubuntu is a flavor of Linux, right? So there are various varieties of Linux. One, for instance, is Red Hat, one is Kali Linux, one is CentOS. You might have heard of a variety of these, or Ubuntu is one of the most popular ones. So it is a Linux based operating system. So in general, most of you will either have a Linux based operating system or a Windows based operating system. So make sure you follow instructions accordingly. Yeah, so this should help you understand a little bit about paths. Once you do that, maybe go through the video again and see if you're able to understand better, right? So you have to set those folders according to the paths on your local machine. For instance, if you have a folder called data in /home/ your username / some folder that you've created, you have to put that for the environment variable in the script that was shown in class. So hope that helps you. In Ubuntu, these codes run in Ubuntu. I didn't get your question. Can you maybe try rephrasing that slightly differently? Okay, discuss about the projects on this course. On what topics do you have to maybe do projects to help you with jobs? So a lot of these models that you're kind of gaining a little exposure to, right, like YOLO and things like that, those are popularly used, but try to get some hands-on experience with. See, one thing you can claim that would be useful for an ML role would be framework experience, right? So you either have PyTorch or TensorFlow based experience, and that would help. The second thing is hands-on with models and deploying them and running them. And again, a lot of the things that are discussed in the course, like YOLO is one example. Again, things like ResNet, MobileNet, bunch of vision-based models I think are discussed so far. And later in the course, I think there are certain other kinds of models as well, right? So using those and being familiar with those, that's again another kind of useful skill to have. Both of those are valuable in a job, in an ML job, right? But if you're applying for a systems or a performance related ML job, then knowing some of the systems concepts, for instance, containerization, Kubernetes, or things like this, mixed precision or quantization, things like that will also have a reasonable amount of value, right? So you can also consider that for those kinds of jobs. And when it comes to a project, think about an application and think about a broad problem statement, right? What is it that you want to do with machine learning or deep learning? Let's say one simple example is, let's say you have some maybe menu cards which have a restaurant's menu, and you want to do some OCR on them and basically get the text out, right? So, and you might come up with even more of a high level problem statement saying that you want to do this in a particular use case. For instance, the same thing instead of menu cards could be a prescription written by a doctor, right? So if you fed this into systems where, let's say 1 mg, where you order medicines, instead of manually selecting the medicine, if I just fed in a prescription, the platform should be able to extract the medicines and then order them, right? So you can think of a concrete use case like that. Then start with looking for the data, looking for the model, and then see if you need to incrementally retrain it with some data that you have on your own, and then see if you can make some performance improvements or accuracy improvements, right? And that would give you like a whole life cycle of this whole thing, and then finally again test it out in a very real world sense, right? Test it out with data that you've not already trained it on and see what you get. So you kind of go through this whole ML pipeline, and again you can do this with any domain or application you like. You can pick a vision based application, you can pick a language based application. For instance, these days LLMs are very popular, right? But one thing with LLMs is they need a lot of memory to run. So unless you have access to that kind of memory, you may not be able to run them. But you can always find smaller versions of models that do very similar things, right? So if you're interested in the LLM sort of thing with things like ChatGPT, I'm sure all of you have tried out. You can try out something like that on the language side, or you can try out something on the audio side, image, video, anything you like, right? So try to come up with a high level problem statement and then see how you can use deep learning to do that. That's broadly what I would say. And then cover all these aspects: training, inference, some optimizations that you could do. That would be a good project for this course. Okay, let's go back to that question. Demo file code, work in your Jupyter notebook because you have Ubuntu. So if your question is will it work because you have Ubuntu, yes it should, unless there are commands that are not compatible with Ubuntu, which I don't think there are any. So all the comments in the demo that you're seeing will work as long as you change the paths and things like that as it is on Ubuntu, right? I don't see any other. Let me quickly scroll through. Make directory, ls, yeah, all of these should work on cat. All of these are Linux commands, they will work on Ubuntu. I don't see any command, but if you run something and then you find an error, then you can always ask. But yeah, I don't overall see anything where you would have an issue with Ubuntu. See, Linux is the most preferred operating system when it comes to developers or development, or so most of the courses that you find, not just this one, most courses that you find will cater to Linux, right? Windows might be the more difficult one, that a lot of things that you find instructions for may not work, right? But by default, all the things that are shown on the course should work on any Linux based OS and will definitely work on Ubuntu. If you're using something like Red Hat or Red Hat Linux, you might have a slight issue because again the package manager and lot of things are different there. But with Ubuntu at least, everything should work out of the box. You will not have issues running demos and things like that. So please try it out, it should work. Okay, glad to have gotten so many questions. Hopefully my answers help clarify at least some parts of your questions. Okay, let's continue with our discussion. So, one optimization you can do is memory consumption to accommodate a large DNN. The other optimization you can do is somehow increase the bandwidth to accommodate data transfers. Then you could use tensor cores for your computation to get a speed up, right? Now here we've already looked at this XLA in one of the previous weeks. So now in this week we will look at mixed precision and transfer learning. So those are the two things. So let's talk about mixed precision, right? So we already I think briefly discussed this, right? Mixed precision is kind of the idea of using two different uh, data types or numerical formats to do an operation. And why is this advantageous? Because it saves you a lot of computation, right? So again, some clarification on terminology. Single precision is FP32, and this is the default one that is used in training. Half precision is FP16 or float 16. So notice that both of these are floating point formats. There are also integer formats like int 8, and you might find references to other variants of int also. Sometimes things like int 4 or a 6-bit integer or things like that. Those mostly come into play with inference, not for training, right? But on training we mostly talk about floating point numbers. And again, why is that so? Is something you can think about. It broadly has to do with how much precision you need, right? So the idea of mixed precision is that you use some computation of FP32 and some computation of FP16. Now again, whenever you reduce the precision, you typically get a speed up or things run faster, right? Basically think about if you had to add 2 plus 2 versus you had to add 1.89123 plus 1.76548, right? The answer might be very close, but just the way you take a lot more time to do floating point computation, hardware is very similar, right? Floating point hardware takes almost an order of magnitude more time to do computations. And you might have seen this in, I think, week 1 or week 2, where remember there was this bar chart showing how much time and how much energy various operations took, right? And you had one bar showing you FP 16 and one more bar that was a lot taller showing FP 32, and then one tiny bar maybe showing you int, right? So this is broadly motivated by that. And mixed precision is supported. So again, some of the concepts are specific to GPU architectures. Yeah, I think I lost connectivity for a while. Can you hear me now? Okay, great. Yeah, I seem to have network issues today. Sorry about that. I switched network, so hopefully it's fine. Let's continue and let me know if there are issues. Today is a bad network day, sorry. Yeah. So again, some features, you will notice this not just about mixed precision but a bunch of other things. Some features are hardware architecture specific, right? So some GPU architectures might support it, some may not. And this prompts a very interesting question: why is that so, right? So if you think about it a little more, you will notice that you need hardware support for some features. So I cannot just do this in software, as in I can say technically, let me do mixed precision in software without having GPU support, GPU hardware architecture support. But remember that as long as you're using the same hardware, right? So in hardware, let's say there is a multiply accumulate unit, right? As long as you're using the same thing, your performance will remain the same. So there needs to be some degree of support from the hardware architecture for this sort of a feature, right? So all the features where you notice something like that, right, where it's hardware dependent or you need something from the hardware, those you will see a note saying that it's only possible on these things, right? And sometimes your software like PyTorch might allow you to enable mixed precision even on a GPU which does not support it, but you will not see a performance speed up unless your GPU supports it. So that is something to keep in mind, and it's a very subtle distinction. So you should understand why this is the case. Then moving forward, so this is the hardware feature that actually supports this, right? Tensor cores. Again, I'm not sure how visible this is, so let's zoom in a bit. So these are some different data formats. FP32, which is a very standard one, right? Which has, again, if you've not seen this, go look up something called IEEE 754, and again you might get a very long paper sort of thing, but maybe look at a blog post about it, or I think there is a Wikipedia and a Geeks for Geeks article on it. So you can look at any of these to get a better understanding, a simpler understanding, right? And if not, I think this article from Google Cloud will also talk about various floating point formats. So I think this is also linked in your slide, but I'm anyway sharing it, so feel free to look at this. So you'll see with machine learning that a lot of new formats have come in, right? Like TensorFloat 32 or bfloat 16, right? Which is a Google introduced floating point format intended mainly for their TPUs. So you'll see that all of these change the number of bits they have for what is called the mantissa and the exponent, right? And this basically determines your range of numbers that you can represent, and this determines the precision. So if you read a little bit about the floating point format itself, then you will understand this. And again you will see with bfloat that it retains the same range as FP32, but the precision is a lot lesser, right? So in a lot of cases you might see something like this, where even here, right, if you observe, the range is still the same 8 bits, but the precision is reduced. So this tells you something about the workload, the machine learning workload itself, that you can deal with lesser precision as long as your range is the same, right? That's what this tells you. So this is again a pictorial representation. I think it has a link to IEEE 754 also, so you can go look it up later and see if that helps. So again, like I was talking, I think we spoke about this in one of the earlier weeks as well, but what are the benefits that you get? So one is a compute speed up, right? So this is going to use your hardware tensor cores to speed up some operations, basically multiplication and convolution operations. So one part of the speed up that you get, one part of the performance improvement that you get is from the compute speed up. The second part that you get is, if you even look at this, you'll realize that it takes this many bits to represent FP32, this many lesser bits to represent FP16. Maybe this box is interfering a bit with the visibility of slides. Yes, so you can see how many bits it takes, right? So because of that, you're going to get some more benefits. For instance, you're going to take lesser memory to store your model. So both training and inference of larger models or neural networks are possible. The other benefit you get is you need lesser memory bandwidth, because again a lot of your data is in reduced number of bits now. So your data transfer operations also are speeded up, right? So in Volta and Turing, which if you remember from here are two of the architectures which support this, there is a 3x overall speed up that is achievable. I see that there's a question, what is momentum and how does it work? Again, since I don't have slides today, I'll try to explain it in the next class before we start with that week's course content. That should help you understand. But in the meantime, I'll see if I can give you a simple resource to read it. Yeah, I think this should help. Yeah, this is a little bit in detail, but the initial parts of it maybe should give you an intuition, and we will discuss it in the next class. So that will anyway give you an idea. But if you want to understand what it is a little bit before that, you can take a look at this and see if you understand. Yeah. Okay, so now, we've spoken about mixed precision and how it's beneficial, right? Let's see how much I have on recap. So we seem to be running a little bit behind schedule today, but that's okay, we'll make up for it. We have quite a bit, but then I think the questions are all easy, so we can take our time. Okay, so let's take a break in about 10 minutes. I think by then we should have finished the recap part of it. So I think that's a logical break point rather than just 1 hour. So we'll do that. So mixed precision training. Again, we already spoke about this, right? As when you use mixed precision, you get a speed up by performing operations in half precision, right? But remember, I think there was a diagram in the last week or the week before that. So you do the multiplication in reduced precision, but you do the addition in full precision, meaning this operand that you have here is an FP32 operand, right? This part is done in FP16. So that's how you get a benefit. And minimal information is stored in single precision to retain as much information in critical parts of the network. So if I were to use something like mixed precision in training, where all should I kind of bring it to half precision? Where should I retain things in single precision? So that's a question, right? So basically what you would need to do is port the model or adapt your model to use FP16 wherever appropriate. And if you have small gradients, right? So machine learning has a lot of issues. You might have heard of things like vanishing gradients or exploding gradients, right? These are all kind of instability issues that arise due to numerical issues. For instance, if you have very small gradient values, you could have some issues. So you do some kind of loss scaling to prevent this, right? So we'll see a little more about this as we go. So let's talk about the porting for this. So what do we do? One way of doing things would be choose an FP16 format for convolution, fully connected layers, tensors, etc. Keep all the hyperparameters from the FP32 training session. Now what could happen if you do this is some gradients, as we discussed a little earlier, some gradients become very tiny or it goes to 0. Why does that happen? Is the range is too narrow and hence you have some kind of an underflow, right? So again, when we talk about range, go back to this diagram and look at what changes between FP32 and FP16. So you'll notice that there is 8 bits here, whereas there's 5 bits here. So that determines the range. So because of that, your gradients might become 0. So then what needs to be done is the gradient value has to be shifted to into an FP16 representable range to match the accuracy of FP32 training session, because the whole idea is that you want to retain as much accuracy as you can, right? If you're going to do this and you're going to lose all accuracy, let's say I gave you a model that trained 3x faster and gave you 60% accuracy as compared to a model that is 3 times slower than this. Let's say it takes x to train, but it gives you 95% accuracy. The 60% just might not cut it, right? So most people will take this trade-off only if the accuracy goes down from 95 to, let's say, 90. 60 is just unacceptable, right? So there are things like that that come into play. So to avoid that, you need to do some kind of scaling to retain certain values and prevent them from becoming zero. So that is the whole loss scaling, right? So again, this tells you a little bit about that. So here again, I don't know if this is very visible. So this shows you pictorially as to what is the representable range in FP16, and it also shows you what kind of values become F0 in FP16. So if you don't understand some of this, please ask, right? All of this assumes that you have a basic understanding of the data formats, you're familiar with the IEEE 754. If not, and this whole thing seems very new and very unfamiliar, ask me, we will go over it in detail in the next class, right? We'll talk about what's FP32, what's FP16, what is this range you see here, this range you see here. I'm assuming that you understand all those things well right now, so I'm kind of doing a quick recap of what was covered. But if that's not the case, please point it out. Tell me that I don't understand this whole data formats very well. Then we'll do a 10-minute session on just data formats. Okay, so yeah, so the summary is gradients may require some kind of scaling. Okay, that's fine. We can go over that next week, right? I'll basically walk you through all of these things a little bit, whatever we spoke about. Basically the formats that we spoke about here, right? We can go over this and I'll give you examples of what this range is, what this precision is, right? You'll understand it very well, and then we'll come back to the same graph and then we'll look at this. I'm sure you'll understand it. So thanks for bringing that up, appreciate it. So we will definitely discuss that in the next week's session. We'll spend 10 minutes talking about that. Okay, so now comes the coding part of how do you do this loss scaling, right? We said that to avoid the gradients becoming zero, we want to scale the loss. How do you do that loss scaling? So again, the recap purpose of loss scaling is to preserve small gradient magnitudes. So how do you do it? That's the process. You scale the loss values computed in the forward pass before you start the back propagation. So, and then before the weight update, you have to do the opposite of this. So here you scaled something, but before you do a weight update, you have to kind of unscale it to maintain the magnitude of updates the same as in FP32, right? So you basically do something and then you kind of revert it back, right? So that the overall magnitude stays the same. So let's look at this. So this is one example of a scaling factor, right? So 1024. So once you do the forward propagation, which is model of inputs, you take the loss and you multiply it by this scaling factor. So this is the step one. Then remember that once you compute the gradients, so you compute the gradients with this new loss, which is the scaled loss, right? After that, you have to unscale it, meaning you multiplied it here, you have to divide it here. It's kind of like reverting the operation. So you take the gradients and you divide it by the loss scaling factor that you had here. That's about it, right? So this is kind of the description of that. Make an FP16 copy, forward propagation, multiply the loss with the scaling factor, back prop, multiply the gradients with 1 by s, complete the weight update. Something for you to think about is we are multiplying the loss by some factor and we are dividing the gradients by the same factor. Does this kind of do what I said it does, right? Theoretically, does it make sense to you? Because these are two different quantities, right? So is it equivalent to basically not doing this? Think about that. Right. Now comes the next question. How do I really pick the scaling factor? In the last slide we said 1024, but how do I know it? Maybe 1024, it could be 512 or it could be something else, right? So you could pick a constant thing, but there might be some trial and error because this scaling factor would depend on the network, the framework, the mini batch size. Yes, you can change the loss scale value, but again it has to be a correct value for that network, for that framework and mini batch size, right? So you will need some trial and error to go to figure this out. So how do you do that? This is the kind of the heuristic or the way you pick that. Choose a value so that its product with the maximum absolute gradient is below 65504, basically the maximum value representable in FP16. The logic here is very simple. If you pick something that's, if you pick a scaling factor that's more than that, you will basically have an overflow because you can't represent this, right? That's what this says, avoiding overflow. That's one strategy that you can follow. I think later there is also a slide that tells you that you can kind of go a little lower, it's a trial and error process, right? You can't really guess it in one shot and get it right. That's the idea. Okay, I think we come to the end of mixed precision now. So basically FP16, forward pass, scale the loss, unscale the gradients and then do the weight update. That's about it. So now comes the second part, right? Automatic mixed precision. Now you don't have to do any of these. AMP basically automates this whole process. So it internally takes care of whatever needs to be done and does it for you, right? So again you see here that there are tensor cores shown, and AMP, you can think of, if this is your PyTorch layer, like your framework layer, this is your neural network on top, this is your hardware. So AMP kind of sits between the framework and the hardware, and then it does whatever needs to be done for you, right? So you just feed a network to AMP and AMP kind of figures out what needs to be done in FP32, what needs to be done in FP16, right? And then runs it on tensor cores, right? So now this we again look at TensorFlow and PyTorch. How do we do this in both frameworks? So here you have a flag, right? You set an environment variable. So this is called an environment variable. You set that to 1. Then after that, depending on which kind of model you're using, you might need to enable some other function as well, right? Enable mixed precision graph rewrite. So it's an experimental feature if you notice, but you can do that, and that's all that you need to do with TensorFlow. Similarly, you will see with PyTorch, what do you need to do? Right, here you have to maybe do a couple of steps. For instance, you have to scale the loss and then call backward, and then yeah, before you need to update the scale for the next iteration. You call things with scalar, and that would update the unscale the gradient. So basically all the steps that you saw, this kind of takes care of that. Define something about environment variables. Sure, let's see if I can find you. Right. So again, this I think we can go over in the next class. It's again something you'd be familiar with if you've used Linux or some form of Unix, but we can take a look at some of these small examples, right? But this article that I've sent you will have a good starting point for you to go through. So again, for people who've not used Linux at all, a lot of things that are mentioned in the course might seem very complicated. Please ask that, right? Because again, sometimes I assume also that you've been using Linux for a while and you know these things. So please ask me explicitly. It's okay if it's a basic question, I don't mind. We can spend 5 minutes on it, right? That's all it takes for you to understand it. So we'll definitely go over that also in the next class, if that will help. Okay, that's the PyTorch side of things. So with that, we come to the end of mixed precision. Now I think we have very little about transfer learning. Let me see how much. Seem to have a lot of recap stuff today. We don't have too much, so we can finish that. So transfer learning is basically, so as the name says, right, you've already learned something and you want to utilize that. So I was earlier also talking about a pre-trained model. So for instance, YOLO, right, the makers of YOLO would have trained it on some data. Now you want to retain that knowledge but train it on some new data, right? That is transfer learning. So this new data is again trained using weights and hyperparameters from the pre-trained knowledge model. So when we say pre-trained model, how do you think its learning is retained? It's retained in the weights of the model and the hyperparameters of the model. So as long as you retain these two, you're kind of retaining whatever the model has already learned, and now you just feed it new data so that it can kind of fine tune or adjust and do the same task on different data. So why should we do this? It takes much lesser data, and if you have lesser data, it's going to take lesser time, right? Yeah, that's the second point, obviously. So lesser training time, and then you also save cost. How do you save cost? For instance, if you run this on the cloud, you will see a cloud provider saying that they're going to charge you by the hour or by how much time you're running a VM for. So that's kind of how you save in cost. Or if you're running it on a GPU that you have at home, you're basically going to be powering, the GPU is going to consume power, right? So that's again a form of cost or money that you spend in the form of your electricity bill. So again, it saves cost. So that's the benefits of transfer learning. So Tau is a framework from NVIDIA. So you've seen some examples with it, I think. So it's again, it stands for train, adapt, optimize. So you can do, mainly it's intended for transfer learning, right? And again, there were some examples in the slides, but I think we have that slide here. So here are a few examples. For instance, you have models for computer vision. So you have things like face detection, emotion recognition, and a lot of these things, right? And you also have some general purpose model architectures like ResNet that I mentioned earlier, VGG, MobileNet. These are all very well-known architectures in the classification space. Similarly, in the object detection, you have things like SSD, YOLO, faster RCNN, RetinaNet, right? And then you have some segmentation models. And then again, you have some models for ASR, which is automatic speech recognition. You also have some models in the NLP space, and again, I'm sure all of you have heard of BERT also, BERT, Megatron, lot of these things, right? So you have a lot of these models available. So these are pre-trained, and then you could kind of fine tune them, right? What is the difference between adapt and optimize? I'm not sure if there was something about this in your course lecture or slides. If not, we can, I'm just quickly looking through it. Yeah, if not, we'll discuss that also in the next class. I'm guessing the adapt kind of refers to the incremental retraining that you do, but let me just check on that and get back to you. Okay, yeah, so this is broadly the structure. So you have a training model, you evaluate it, then you do some pruning. This could also be one adapting a model, right? Basically, let's say you have a certain amount of memory and therefore you cannot accommodate a very large model. So you might want to prune the model or trim down some of its layers, and then you want to retrain it and test it, then run inference, right? This is an example of a pipeline. So with that, I think we're at the end of our recap. So before we take a break, any other questions, please put them on chat and we'll definitely take them. Okay, so if there are no questions, let's take a break now. It's 8:28, so we'll come back at 8:33. I'll demo file again. I don't have access to any demo files, so you will have to check on the Google group, the discussion forum that's there, and you might get access to it. So yeah, we can do that. Mm, let's resume at 8:33. Feel free to take a short break and come back. Okay, let's continue. How do I connect with the team? Again, the Google forum is the only way, so you can ask your question there and then they will get back to you. Okay, let's move to the questions part of today. Idea of mixed precision is the combined use of, you have four options, think about it. This should be pretty obvious from whatever we spoke about. A, FP32 and FP16. Okay, any other answers? Anyone else? No? Okay, let's look at the answer. It is A, FP32 and FP16, and if you don't remember this, just go back to the recap slides and look at them. It is, you'll understand why. Okay, so let's move on to the next question. Any doubts here? Please ask again. I'm not going to spend too much time here because it is something that we already covered. Yeah, how many bits are used to represent exponent field of B float? 16. We have one answer saying D. Any other answer? I'll wait a few seconds. Okay, so let's take a look. It is the 8-bit. I think here's the other, here's the link that I probably previously shared on chat, but if not, you can always take a look at this. So this will tell you about the B float format. But if you quickly look here, right, you'll see this is the B float format, and you'll see that the exponent has 8 bits and the mantissa has 7 bits. So this is purely a recall question, but it's a good way to get familiar with B float and how it helps with performance. Let's move on. Which of the following is not an optimizer? Adam, SGD, Adagrad, Softmax. Any answers? Okay, D. Which file do you mean the screenshot? Which file are you referring to? This screenshot, oh, the screenshot is from some other, this blog that I've linked here. So sometimes the references that I put as like a clarification to a question is from an external source. Whenever I do that, I give a link to whatever source that I put. So this link will be there in the slides. So it will be posted right after this session in the same Google Drive folder, right? So you can take a look at this. Yeah, so this is the, I think, the drive link where all my slides are uploaded. So shortly after this session, you can check, this will also be uploaded and you can pick up the link from here. Okay, which is not an optimizer? Yeah, answer is D, softmax. I think a bunch of you got it right. As someone said, it's an activation function that scales numbers into probabilities. So it's a output is a vector with probabilities of each possible outcome, and the probabilities sum to 1. Again, I've given you a link if you want to read a little more about softmax. These are all possible optimizers. You've already heard a lot about SGD. You may have heard of Adam and Adagrad as well. They're used for the exact same thing. Let's move to the next question. Which of the following statements are not a benefit of mixed precision? Think about this. We also discussed this directly, so it should be very easy. Okay. 4 is what exactly? D, none of the above. Okay, I'm guessing it's D. Okay. Any other answers? If not, let's take a look. It is D. So remember we spoke about the computational benefit that you get by using tensor cores. You also spoke about requiring less memory and therefore training of larger networks are possible. Also spoke about lesser memory bandwidth. So all of these are benefits. So which of them are not benefits? None of the above. So D is the right answer. Let's move on. This is a bit long. AMP automates process of training in mixed precision. Which of the following best summarizes the process? So this again about how to use AMP in TensorFlow. So you can take a look at all of these and try to recall which one was similar to what we saw. We did look at this in the recap. So we have one answer saying A. Okay. Anyone else? Okay, we have one answer saying A, one more saying A. Okay, let's take a look. So it is A. So you declare your optimizer, then you pass that and enable the mixed precision graph rewrite, and then you kind of call your minimize with the loss. So this one is wrong because the optimizer cannot be initialized here when you're doing this. So the optimizer has to be initialized at the beginning. Then here the issue is what you're passing to the graph rewrite, right? And this again same comment as before. So A is the right answer. Let's move on. Transfer learning is a process of using learned features from a pre-trained model to train. Uh, this quiz was shared in last class and one wrong answer. I didn't understand which was the wrong answer. Let's keep going. You can answer me whenever you know. Learned features from a pre-trained model to train same data. New features from a pre-trained model to train new data. New features from a training model to train new data. Any answers? So are you talking about this particular question? Okay, A, answer A. Second or third question? Okay, okay, everyone thinks it's A. It is A. So you take a pre-trained model and you use the learned features from that to train new data. That is transfer learning. Which of the following is not an example of a pre-trained model that can be used for object detection or image classification? D, faster RCNN. Okay. Anyone else? Okay, the answer is D, faster RCNN. So can you tell me why that is? So you have the classification chart here and faster RCNN is listed here. So can you tell me why it's faster RCNN and not any of these? All others are used for image or video classification. Okay, but this is listed under object detection, right? And the question also says object detection. Think about that. Okay, let's move to the next question. This is again a long one. So this is asking you about NVIDIA Tau pipeline, right? The order of things that are used, order of steps that are used, and you can look at all of these options and see which one is the right one. D, okay. D, okay. Okay, let's take a look at the answer. It is D. So again, it's directly from this pipeline that you saw, right? But let's try to think about it logically. So option A says you train, you evaluate, then you have your input and specs, and then prune. So the logical conflict here is that to train the model, you will need both of these things. So that's not possible. Right, let's take a look at B. Right, B says prune the model, but you can't start off with pruning the model. You have to first train the model. Right, pruning is something you do after that, right, as an adaptation. So this is also wrong. Then here you start off with input specs, but again you're pruning before you train, which kind of breaks the flow. So this is also wrong. Now if you look here, you take the input and the specs, you train, you evaluate, then you prune, then you again do a retraining and testing, and then you do an inference. So this is the correct order of things that happens in Tau. Okay, let's move to the next question. Which is not true about transfer learning? Think about it. Again, we went over this, so this should also be very easy. All three are correct, so D. Okay, anyone else? Anyone else? We did discuss this in a slide, right? So it should be evident. If not, if you don't remember the slide, at least think about what is transfer learning and then think about which of these makes sense. Okay, if you still don't have an answer, it is D, none of the above. So it requires less data to train, which basically contributes to a reduction in training time, and because you have lesser training time, you are able to save cost, right? Basically operational cost, or if you are kind of renting a cloud resource, you also save on that. So so all of these are true. None of the above is the right answer, because the question is asking about what is not true. Okay, last question. Tau stands for, which is the right answer? C. Okay. Anyone else? Cloud resources is one of the examples you gave today. Yes. Any doubts on that? C. Okay. Okay, no doubts. Great. So yeah, I was talking about the cloud in the sense of if you rent a VM, right? Or if you rent things from the cloud, then you have to pay based on how long you're keeping that active, right? So in that case, transfer learning would cause a reduction in cost. If you're running locally, then your own power consumption would be of cost to you. So that's the way you think of it. So with this, again, it's straightforward. It stands for train, adapt and optimize. So with that, I think we are done with all the questions today. We still have a good 10 minutes. So any other questions or doubts or things that are not clear, please ask, and then we will definitely address them. If you have no doubts or questions, thank you so much for coming to this session, and thank you for keeping it interactive. And I look forward to seeing you next week. Feel free to drop off. I will stay a couple of more minutes to see if any of you have questions. Yes, thank you so much. You can drop off if you have no doubts. Thank you. Thank you. See you next week. Feel free to drop off if you have no questions. Yes, whatever you asked today, I'll definitely clear. But in the meantime, please try and go through some of the links that I shared as well. That should help you with some of those things. Define video 4 of session 6. Define in the sense? Okay, summarize it. I can take a look at that. Video 4. Okay, optimizing. So basically transfer learning. Sure, I can do that for you in the next class. Any other questions, comments? Sure, please ask. How can you make a new model yourself? Interesting question. So a good point to start would be try out a simple one layer model, right? So you can look at this module called multi-layer perceptron, which I think, I don't know if PyTorch also has this, but scikit-learn will definitely have a example on this. Let me see if I can send that to you. So this is basically a one layer model with one input layer, one output layer, and you can have one hidden layer or multiple hidden layers, but this is a very small, very um, small thing to do, and it's a good starting point, right? So you can try this out either to classify things uh, or to do a regression sort of thing, right, where you're predicting some value. And then after you get a good handle on this, you can look at some of the more advanced architectures, and see if you can start with one of those and modify some things according to your application. So that would kind of, I think, help you. Two projects. I am not sure if that was something that was told to you. I am not sure if there are two projects in this course. Ah, okay. That's the last two modules, I think. Yeah, yeah, yeah. I think they're intended at they're kind of like an example use case, right? I think the last 2 weeks will have that. Yeah, that should probably give you two good applications of the course. Yeah, yeah, I do see that smart city, and I don't see the health part. I think I see some text based stuff. I see some classification, machine translation. Maybe this was changed in this iteration of the course. But basically, you can, I think you're talking about week 11 and week 12, right? That's basically it. I will just put a summary of that. One project yourself parallelly. Yes, sure. Feel free to do that. Yeah, this is what I see in week 11 and week 12. So that should give you some good use cases and application domains and things that you can do. Okay, I think that's all the questions we have for today. So see you guys next week, and thank you so much for joining.